When U.S. warplanes roamed Venezuelan airspace as if unopposed, was it truly because Chinese-made radar systems were blind? Behind this pointed question lies a complex web of equipment performance, system-on-system confrontation, and information warfare, far too intricate to be dismissed with a simple, effective, or ineffective, any sweeping judgment detached from specific battlefield conditions, force ratios, and systemic support inevitably falls into the trap of oversimplification. First, we must acknowledge a fundamental fact. Venezuela's JY-27 series long-range surveillance radars, imported from China, had their design specifications clearly stated at the Zhuhai Air Show, a maximum detection range of 500 kilometers, capable of detecting and tracking quasi-stealth targets. These 5 words constitute the official description, precisely delineating its capability boundaries. It is primarily designed to counter aircraft like Russia's Su-57 or South Korea's KF-21, which possess some stealth capabilities, but are not fully stealthy. Rather than serving as a mythical weapon specifically engineered to counter top-tier 5th-generation stealth fighters like the F-22 or F-35, both exaggerating its capabilities beyond measure and deliberately downplaying them are inconsistent with the facts. More critically, there's the issue of quantity. Venezuela's entire military operates only 3 units of this radar type. Within the vast national air defense network, 3 radars can establish an extremely limited surveillance coverage area. They function more as supplementary reinforcement points for key directions rather than a comprehensive, all-encompassing network. In contrast, Venezuela's air defense forces still actively deploy at least 10 US-made AN, TPS-70 series radars. The actual effectiveness of these American systems against electronic suppression and stealth penetration by Venezuela's newest generation of fighter jets is itself highly questionable. Blaming the failure of the entire air defense system on Chinese radars, which are vastly outnumbered, is logically inconsistent. This U.S. airstrike operation was a textbook demonstration of modern system-breaking warfare. The deployed aircraft included F-22 and F-35 stealth fighters, A-18G Growler electronic warfare aircraft, F-A-18E, F Super Hornets, B-1B strategic bombers, and carrier-based aircraft from aircraft carriers, and amphibious assault ships, all supported by a massive aerial refueling fleet. This was not a simple aggregation of aircraft but a meticulously designed combination. Stealth fighters penetrated defenses and conducted reconnaissance. Electronic warfare aircraft implemented electromagnetic suppression and soft kill capabilities, while non-stealth strike aircraft executed precision destruction within the secure corridors they had opened. This integrated strike model, combining stealth, electronic warfare, and network-centric capabilities, aims to systematically dismantle an adversary's air defense networks, command structures, and counterattack capabilities. Faced with such a dimensional strike, the vast majority of nations lacking comprehensive system-on-system capabilities struggle to respond effectively. This model has been repeatedly validated in the 2022 Russia-Ukraine conflict and the 2025 Israeli airstrikes on Iran. Venezuela's passive stance thus fundamentally reflects the systemic failure of its entire defense apparatus. When confronted by overwhelming superiority, footage widely circulated shows its mainstay Su-30 and F-16 fighter fleets unable to scramble for interception, while ground-based air defenses, including Russian-made S-300 and Buk missile batteries, were destroyed. Even the Lynx all-terrain vehicles imported from China suffered damage during the assault. These events point to a single reality: the entire chain, from reconnaissance and early warning, through command and control, to fire interception, may have been suppressed or crippled. Warfare is a contest of systems, not a duel of individual weapons. Against this backdrop, isolating the question of whether the 3 JY-27 radars were operational or acquired targets overlooks the complexity of modern air combat. Amid intense electronic warfare, radar activation risks immediate detection and destruction by anti-radiation missiles. Strategic power cycling, positional maneuvering, and camouflage to preserve assets constitute core elements of high-tech air defense operations. Even if a radar momentarily detects a signal, the greater challenge lies in whether this intelligence can be effectively transmitted, identified, and translated into decisions within a command network that may already be compromised or infiltrated. The deeper issue lies in the comprehensive influence the United States has cultivated over decades in its own backyard. From the precision of intelligence gathering and the timing of operations to the organized questioning of Chinese equipment performance in the post-event media landscape, these actions reveal this was not merely a military operation, but a multifaceted campaign involving political, military, and public opinion dimensions. Maduro's son's statement that history will reveal who the traitor is, though unverifiable, sharply highlights potential vulnerabilities in internal security. Even the most advanced equipment becomes significantly less effective if command communications are compromised, key personnel are turned, or operational plans are leaked. Over a century of deep-rooted influence in Latin America has granted the United States immense advantages in intelligence networks, proxy operations, and elite-level influence. This erosion of soft power can sometimes prove more lethal than direct hardware confrontation. Foreign media's selective focus on Chinese radar constitutes a meticulously orchestrated cognitive warfare campaign. Its objectives are threefold. First, to divert international criticism away from U.S. military aggression and America's long-standing interference in Latin American affairs. Second, to undermine the international market reputation of Chinese military products, particularly high-end defense systems. And third, to project psychological deterrence through the narrative of absolute U.S. technological superiority, warning other nations against seeking non-American security solutions. This narrative deliberately sidesteps critical issues. It ignores systemic competition, overlooks Venezuela's long-standing deficiencies in defense capabilities and internal challenges, and dismisses the fundamental nature of asymmetric warfare. Instead, it simplistically frames the complex incident as a failure of Chinese equipment, a highly misleading approach. Objectively speaking, the JY-27 radar, as a long-range surveillance system operating in longer wavelengths, represents a deliberate technological path designed to counter low observable targets. Physical principles dictate that specific frequency bands offer theoretical advantages in detecting certain characteristics of stealth aircraft, which is why multiple nations pursue such systems. However, it also suffers from drawbacks like relatively low precision and susceptibility to jamming. Within a robust air defense network, it should serve as an early warning component, complemented by more precise fire control radars, low-altitude gap-filling radars, fighter aircraft, and air defense missiles to form a multi-layered defense network. Expecting a single radar model to independently counter an entire airstrike system defies military common sense. China's foreign military sales provide products that meet contractual specifications. Their ultimate combat effectiveness heavily depends on how users integrate them into their operational systems, coupled with effective utilization, maintenance, and tactical coordination. This incident serves as a stark lesson in modern warfare. It vividly demonstrates how a side possessing comprehensive information superiority, systemic advantages, and battlefield initiative can systematically suppress a nation with fragmented systems, potential internal vulnerabilities, and a strategic defensive posture. Its implications extend far beyond discussions of radar performance. National defense modernization is a systemic endeavor encompassing technological equipment, command structures, personnel training, combat readiness discipline, and internal security. Merely acquiring a few advanced weapons without sustained investment in system development, personnel training, and strategic autonomy cannot secure genuine security. For nations focused on defense development, the critical questions lie in how to build a resilient national air defense system, how to ensure the survivability and continuity of command chains in high-tech localized conflicts, and how to safeguard sovereignty and security amid great power rivalry. These may well be the most profound and universally relevant lessons this incident has imparted.